Good evening, ma'am.
Good evening, Rohini. How are you?
Fine, ma'am.
Good. Ashwath, are you there?
Yes, ma'am.
Okay,
Ma'am,
good
like
evening.
I have tomorrow exam, science exam. I have chapter light, forest,
Hmm.
motion in time, electric circuits. Can we revise chapters?
Ashwath, this is not possible to revise at this moment because the other children also will be joining the class, right? And I was taking acid bases and salt chapter. I was teaching all those reactions. So in within 40 minutes or 1 hour, it is not possible to revise so many chapters. So what you can do, Ashwath, you just revise it and whatever the doubts you have, you share with me, okay? And I'll explain you through the audio.
Okay.
Hmm.
Good evening, ma'am.
Good evening. Should we start, children, then? Yes, Rohini, Ashwath, and Divyesh. Can we start?
Yes, ma'am.
I think last time only, Divyesh, you were there, right? In the acid bases and salt chapter, you and Rishit.
Ma'am, me and Rishit.
Now today again, Rohini and Ashwath, two different children are there. So okay, let me just quickly revise that part, and then we will be moving forward to it. Just a minute. Is my screen visible?
Yes, ma'am.
Okay. So last time we have discussed, we have actually started the acid bases and salt chapter in detail. So based on the nature, it will be of three types: acid, bases, and salt. Acids, they are the substances which will be taste sour in nature. And then since they are sour, they are called as the acids. The term acid has been derived from the word called as acidus. So this acid word we have got from the word acidus, which means sour. Then it's a compound which will have the hydrogen. So always keep in mind the acid will have one hydrogen in them compulsory. Like hydrochloric acid, they have the hydrogen in them. Then acetic acid, CH3COOH. So they also have the hydrogen. So whatever the acids are there, they will have compulsory hydrogen in them. Sulfuric acid also has hydrogen. Nitric acid has also a hydrogen. So each and every acid, which whatever are there, they will have the hydrogen in them. So they can be natural present or they can be there. We can eat them. Like lemon and orange. Naturally, they have the acids in them. Now, coming to the properties, they are sour in taste. They will be turning the blue litmus to the red. and they can corrode the metal, like the aluminum, iron, they can corrode them. And that is why always the acid are being stored in the glass. So the reason why they are stored in the glass, so that they cannot corrode that container. Then acids, they are soluble, we can mix them in the water, and they also help in conducting the electricity. Then after this, we have started with the reaction. So when the acid reacts with the metal, they will be forming the salt, and also they will be producing the hydrogen. So since here the some of them does not know what are metal and non-metal, I started with the metal topic. So metals, they are basically the solids. They are shiny in appearance, and also they are good conductor of electricity, heat and electricity. Then they are malleable. So the metals, they can be hammered. We can, through the hammer, we can convert all the metals into the sheet. Then they are ductile. Ductile means we can convert them into the wire. As you can see, like, when you have any kind of the wire which is there for the electricity, that will have the copper. So that copper is being converted through the ductile process. Then whereas non-metal, it is opposite. It is brittle, it is dull, it cannot conduct the heat and electricity. Then some of the metals and non-metals examples we have discussed. Metals are like iron, gold, silver, copper, aluminum, sodium, magnesium, zinc. Then lead, nickel, titanium, chromium, and tungsten, they are the metals. Then some of the non-metals are oxygen, nitrogen, sulfur, carbon, chlorine, hydrogen, phosphorus, iodine, fluorine, neon, helium, argon, krypton, and the selenium. These are some of the example of the non-metals. Then, but they are certainly, as I told you, that all the metals are shiny in nature. They can be converted into the sheet, they can be converted into the wire, but some exceptions are also there. For example, mercury. Mercury is the only metal which is at the liquid form. It is not present in the solid form, but it is present in the liquid form at a room temperature. The second one is gallium and the cesium. So the gallium and the cesium, they have the very low melting point, and they can melt easily in your hand. So if you take the gallium and the cesium in your hand, easily it can melt down. Then third point, sodium and potassium. They should be actually hard, but they have the limitation. It means they are soft in nature, and they can be cut it with the knife. So the metals, we cannot cut them with the knife. They are hard, but these two are the metals which can be cut through the knife, like the sodium and potassium. Then aluminum, they are light in weight and they can be used in industries. And the zinc, they are not malleable, or they cannot show the ductile property. So that is what we have discussed. Now similarly, we have the, just a minute, we have the non-metals also, which has some certain limitation. Okay, just a minute. So there are some non-metals which have the limitations, so that we will be discussing. Rohini and Ashpat, am I clear what we have done last time?
Yes, ma'am.
Okay, so starting. Okay, so going for the limitation. So there are some limitation, or we can say some exceptions are there, which will be working in the case of the non-metals. So actually, non-metals should be what? They should not conduct the electricity. They cannot be converted into wire. All those things are there. But here there are some limitation, like non-metal. Okay, non-metal exceptions are there. So if I say generally non-metal, they can exist in the form of the solid, or they can be there in the form of the gas also. So either they can be solid or they can be gas. But the first one, it is the bromine. Bromine is a non-metal which is a liquid at a room temperature. At a at room temperature. So bromine is a non-metal, which is what? Which is the liquid. So generally the non-metal should be either the solid, or they can be the gas, but bromine is the non-metal which is liquid. The second one is non-metal should be generally dull. But when we talk about the graphite and iodine, they are shiny in appearance. They are what? They have a shiny surface. So generally the non-metals will be dull, but these two, graphite and iodine, they have the shiny surface. Then coming to the third one, the non-metals do not conduct the electricity. We know that the non-metals cannot conduct the electricity, but the graphite, which is a form of carbon, what they can do? They can conduct the electricity, and that is why we say that it is a good conductor of electricity.
Ma'am,
Am I
pencil
clear?
needs are made out of graphite, right?
It has the lead actually in that. Pencil has the lead, which is a type of the graphite only. Okay, and now why it is able to conduct the electricity? Because this graphite has what? This graphite has the free electron. So what happens, since they have so many free electrons, because of that they will be able to produce the electricity. So generally the non-metals, they will not be conducting the electricity, but the only non-metal which conduct the electricity is the graphite. So I think others also have done. Shritesh, clear? Rishit, am I clear?
Yes, ma'am.
Adrit?
Yes, ma'am. Yes, ma'am.
So this we are learning actually in depth. We are not touching your NCRT book right now. So we are going beyond that. So non-metals, we were discussing what are the exceptions for it. Now moving to the fourth point, if I talk about the non-metal, they are brittle. Brittle means they can be broken down easily. They can break down easily. And we cannot convert them into the wire, or we cannot convert them into the sheet. But there is the non-metal called as carbon. So carbon fibers are there, which actually is made from the graphite. So carbon fibers, they are derived from the graphite. What they are? They are strong as well as they are flexible. So it means they are not brittle. We cannot break them easily. So carbon fiber is a type of a graphite which is strong. They should be actually brittle, but this is the exception where they are strong and they are flexible. They cannot be broken down easily. Then next one, the non-metals should have low density. The density should be low. But there is a non-metal called as diamond, which is actually the carbon is an extremely, it is an extremely dense non-metal. It has high density. These questions actually, they will be asking you in the entrance exam, in the government, when you prepare for the government exams and all. That time they ask you these examples. So like name the non-metal which is extremely dense in nature. So like this they ask it. Then sixth point, the non-metals have low melting point and the low boiling point. But diamond is a non-metal which has a very high melting point. It has a very high melting point. So almost very high melting point they have. So then the next one, seventh one, non-metal do not produce sound when struck. So whenever, uh, they are there, they do not produce any kind of the sound. But diamond, if we talk about the diamond, they can transmit the sound waves efficiently. So if you take the diamond and if you place them somewhere, so what happens through them, that sound can be travel easily. So it acts as a source of the transmission of the sound. Whereas the other metals, they do not create any kind of the sound when they struck to any other surface and all. And the last one is reaction. Okay, one more. Okay, reaction with the metals or reaction with the acids. So generally, non-metals, they will not be reacting with the acid. Always the metals will be reacting with the acid and they form the salt. But non-metals, they do not react with the acid. There are some gases like carbon dioxide and sulfur dioxide. So carbon dioxide is CO2, sulfur dioxide is SO2, which dissolve in water to form acids. So what they will be doing? They will be dissolving in water and they form the acids.
Ma'am, that's how acid rain is formed.
Correct. That is how it will be forming with the nitric acid and the sulfuric acid. So these are the some of the limitation, or we can say some of the exceptions to it. Now, the reason why I have explained you this in the detailed way, because in the last class, we started with the property where I said that acid reacts with the metals, and what do they form? When
Salt
acid reacts with
plus
the,
hydrogen
yes,
ions.
they will be forming salt and the hydrogen gas will be released. Shrutej, Rohini, Ashwath, Adrit, do you know this? Acid reacts with the metal and they form these salts, and also they will be releasing the hydrogen gas.
Yes, ma'am.
I was absent last class, so
Okay, so this is the okay. I'll just tell you. So whatever the acids are there, Shrutej, and whatever the metals. Actually, the name of the metals we have discussed last time in the last class. These are some of the metals I have explained in the last class, like iron, gold, silver, copper, aluminum, sodium, magnesium, zinc, lead, nickel, and titanium. These are some of the examples for the metals. Now, when we talk about the metals, it means they can conduct the electricity, they can produce the electricity. They are they are solid. Then they can be converted into wire. They can be converted into the sheets. So these are some of the properties of the metal. Whereas the other side, you can see the non-metal, where oxygen, nitrogen, sulfur are there, where they do not conduct the electricity, they do not produce electricity, and we cannot convert them into sheet, or we cannot convert them into the wire. So this we have studied metals and non-metals so that I can explain you the reaction between acid and metals. Okay. So when any acid reacts with the metal, what do? They will be forming the salt, and also they will be releasing the hydrogen gas. So this is the rule. Whenever an acid reacts with the metal, it forms the salt and also will be releasing the hydrogen gas. Now, in your book, no examples, nothing is being given. This is very, very useful for your grade 10 to understand this in detailed way. So what kind of acid I'm talking about? What kind of the metals we can take? What is the different type of salt we will be getting during the reaction? So I'll be explaining you with the help of the example here. Okay. So the first example here is reaction of zinc with hydrochloric acid. Reaction of zinc with hydrochloric acid. Now, what is the symbol of zinc, children? Zinc is written
Ma'am,
as
ZN.
capital Z and small n. Azrit, Shritesh, do you know the symbols of the metals and non-metals, the elements?
no.
No. Rohini, do you know the symbols of the metals and non-metals?
No, ma'am.
See, last time I taught them the symbol. So zinc, it is written as capital Z and small n. Okay. So each and every element, whatever are there on our earth, they will have the name and the symbol. Like iron is written as Fe, capital F, small e. Gold, it is written as capital A and small u. Silver, it is written as capital A and small g. Copper is written as capital C and small u. Aluminium, it is written as capital A and small l. Sodium, capital N and small a. Fine. So symbols are there. Again, I'll share this sheet in the group so that you can learn them. Okay, Shritesh, Adrit, Rohini.
Okay, ma'am.
Okay, ma'am. Okay, ma'am.
And children, see, be a little interactive in the class, because there is no use of teaching then, in huge way or in depth way if you don't respond. When you respond, see, whether you are aware or not aware, just let me know so that, I can teach you again. If you wanted to have again discussion, we can have the discussion so that at least you will be able to understand it, how it is, how it works. So here Zn means zinc is capital Z and small n. Hydrochloric formula
Ma'am,
is
it's
capital
HCl.
H, capital C, and small. Correct? Now, here it is mentioned clearly reaction of zinc with hydrochloric acid. Now, this zinc is what here? It is a metal or non metal?
Metal. Ma'am, metal.
Metal. Okay. And what is the
Ma'am, it's a acid.
hydrochloric acid?
It's a acid, ma'am.
Correct. It is the acid. Correct. Now, can I write this equation as Zn plus HCl? Can I write that?
Yes, ma'am.
Yes,
Is
ma'am.
equals to
Now, can you tell me what will be forming here?
Ma'am, salt plus
Z-
hydrogen.
Ma'am?
Yes, salt plus hydrogen. But now, what type of salt it is being formed? It will be forming here ZnCl2
Yes.
plus H2. Fine. Zinc is a metal here. Zinc is what? It is a metal here. HCl is what? It is the acid, which is hydrochloric acid. And as already mentioned in this above formula, about reaction, that it forms a salt. And here the formation of the salt will be ZnCl2, which means it is the name of this salt is the zinc chloride. It is the zinc chloride, and plus also they will be releasing the gas called as the H2.
Ma'am, how
Okay.
did the two came under Zn and Cl?
Very good question. How does the 2 has come here, right?
Yes, ma'am.
It is because of the balancing the equation. Balancing the equation. Now, in the chemistry, this plays a very important role, that always whatever the reactions are there, it should be present in a balanced way. Now, how to balance? See, how many zinc are here? What is the number of zinc here?
Ma'am, 1.
1, right? And how many zinc number is here?
Ma'am, 1.
1, correct? How many H is here? Hydrogen, how many are there?
Ma'am, 1.
1. Okay, I'll write with a different pen, right? Okay. So here hydrogen number is 1. How many hydrogen number are here in this part hydrogen?
Ma'am, 2.
2. Now, is it balanced 1? One side we have 1 and the other side we have the 2?
No.
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 That is why to balance it, what we will be doing, we will be adding 2 here. So it will become 2HCl. Okay. Now again we will be checking after adding the 2. Let us check again whether all the elements are in balanced form or not. So zinc was already 1 1. Now hydrogen, how many hydrogen here on the left hand
Ma'am,
side?
2.
2. And how many on the right hand side?
Ma'am, 2.
2. Now here how many chlorine are there?
2.
2. And how many are here with the chlorine?
Ma'am, same 2.
2. That is how it has come down. Because if you write the 2 here, I'll just write it here. If I write 2 here, then what happened? The number of zinc
Ma'am, the
also will
zinc
change
will also
into
increase.
2. It will increase to 2. That is how it goes down there. Am I clear, Rohini, Shritesh, Divyesh,
Yes, ma'am.
Rishit?
Yes, ma'am.
Can you explain
this is-
once again, like how did we get the 2?
Come again, come again.
Like I didn't understand how did we get the 2? Can you explain once again?
Which 2 you're talking about? The chlorine 2?
Yeah, HCl2.
Okay. See, and who asked me this question?
Ma'am, Rohini.
Rohini. Okay, okay. I'll just explain you again. Rohini, see, what happens whenever we are writing the equation, generally we will be writing like this. So I told you Zn is there. Zn is there. Plus HCl is there. Okay, when Zn reacts with the HCl, it produces ZnCl2 and plus H2. Now, in the chemistry part, it is very important that the LHS should have the equal number of atoms in the RHS. What is LHS and RHS?
Ma'am, left hand side and right hand side.
Correct. Left hand side and the right hand side should have the same number of the atoms available there. Now for that, let us check each and every element. Now we have the 3 elements here. Zn we have, then we have the hydrogen and we have the chlorine. Correct? Am I correct, children?
Yes,
Yes.
ma'am.
Now I'll tell you more easier way how to check it. This is only for children initial time when you are learning it. Once you understand this, it will become easy for you to check it directly. Okay, I'll explain you easy way to understand it. Okay, I have written like this. Now zinc we have, hydrogen we have, chlorine we have. Now Rohini, tell me, in the left hand side how many zinc are there?
Ma'am, 1.
1. In the right hand side how many are there?
Ma'am, 1.
Correct. So that is why nothing, only one you can see there. Now coming to the hydrogen, how many hydrogen are there in the hydrochloric acid?
1.
Correct. On the right hand side, how many hydrogen are here?
Ma'am, 2.
Correct, 2. Now, are the numbers same? 1 and 2 on the both sides?
No, ma'am.
No. That is why what we will be doing, now we cannot decrease the number on the right hand side for the hydrogen. So that is why what we will be doing, we will be increasing the number on the left hand side. So that is the reason we will be adding 2 here. Now once we add 2 here, so how many hydrogen are there on the left hand side now?
2.
Correct. On the right hand side now?
Ma'am, so like in hydrochloric acid, Cl also we need to increase.
No. See, automatically if I am adding 2 here in the front part, it means that 2 is for this also and for this also. But right now I'm talking only about the hydrogen. So here hydrogen is 2 and here is how many hydrogen we have?
2.
Correct. So that is again how it is balanced now. So earlier on the left hand side, 1 hydrogen was there. So to make it balanced, we have added 2 here. Okay. Now come to the chlorine part. How many chlorine are here on the left hand side?
2.
Correct, 2. Okay, because this is calculated. This 2 is the front hand side. This 2, if it is written like this, it is for the both the kind of elements. And on the right hand side, how many chlorine are there?
2.
Correct. So now all the elements are what? They are the balanced one. And that is the reason here in the Cl2, this 2 is coming down. If I am writing it as 2ZnCl2, so what happened? How many number of zinc then it will become on the right hand side?
We need to put 2.
Yes. So then it will be wrong answer. That is why this Cl will have the 2 down. It means only for that chlorine, the number of the atoms are being increased rather than increasing for both the compound. Am I clear?
Yes, ma'am. Ma'am, but the equation is only correct after we added the 2 in LHS, right? 2H2.
Yes.
Ma'am, so zinc plus HCl is not the actual.
See, Kshitej, see, if I talk about your normal, NCRT book or your grade 7 book or any book you take for the grade 7, according to that, it is correct. But what happens when you go for the grade 10, there it will be finding it as a wrong because always whatever reactions we write, we should write in a balanced way. So if you learn it now also, it will be helpful for you later. But if you write according to the grade 7, if you write ZnHCl, which gives salt, ZnCl2 is also correct.
Okay.
Fine, but we can correct it. Right now we know how to balance it, we can do it. Okay, we'll go for the second example for the better clarification. Okay, before that, let me explain what happened in the reaction. I hope children, this is the easy way you have understood it, correct?
Yes, ma'am.
So one element you have to take LHS and right hand side both have should the same number of the atoms there, and if it is not, then you have to increase the number of the atom where it is less in number. All right. Now, what happened when we talk about this reaction where I told you the zinc will be reacting with hydrochloric acid, the salt is formed, and name of the salt is zinc chloride.
Zinc chloride.
Now, yes, in this case, the hydrogen which has been formed, that will be coming out in the form of the bubbles. Okay, that will come out in the form of the bubble. Now, going for the next reaction of iron with hydrochloric acid. Reaction of iron with hydrochloric acid. Now, you tell me what is metal here?
Ma'am, iron.
What is the symbol of iron?
Ma'am, capital F and small e.
Correct, capital F and small e. So, can I write this equation as Fe plus hydrochloric like this?
Yes, ma'am.
And then what it should form? It should form a salt, correct?
Fe
Yes,
to
ma'am.
Cl.
Ma'am,
Yes.
FeCl2 plus H2.
Correct. Very good. It forms a salt called as FeCl2. Now, this is iron here, which is a metal. This is the acid, which is the hydrochloric acid. This is the salt, which is called as the iron chloride, and this is the hydrogen. Same way. Now, see, what you can do, you have to check it whether it is balanced or not balanced. So, let us see. We have the iron, we have the hydrogen, we have the chlorine. Now, tell me on left hand side, how many iron are there?
Ma'am, 1.
One. On the right hand side?
1.
One. Now hydrogen, how many hydrogen on the left hand side?
Ma'am, 1.
On the right hand side?
2.
Ma'am, 2.
So what we should do now?
Ma'am, we have to increase the hydrogen on the left hand side.
Correct. We have to increase the number of the atoms, the two in numbers on the left hand side. So when we make it 2, then 2 hydrogen, it will become on left hand side. Now coming to the last one, chlorine. How many chlorine are there on the left hand side?
Ma'am, 2.
2. On the right hand side?
2.
Ma'am, 2.
Correct. So now it means it is a balance because on the left hand side, right hand side, it means on the reactant side and on the product side, both have the same the number of the atoms. Clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Now I'll give you the next reaction which you should try solving it. Okay. Reaction of magnesium. Reaction of magnesium with sulfuric acid. Okay. Reaction of magnesium with sulfuric acid. So you should try solving this. Magnesium is written as, what is the symbol of it?
Ma'am, Mg.
G.
G.
Then sulfuric acid formula?
Ma'am, H2SO4.
Yes, capital H, then 2, and then capital S, capital O, and then 4. And then it will be giving what it should give.
Ma'am, MgSO4 plus H2.
H2.
Very good. Now I think you have understood how to break it down. Okay. Now here Mg stands for the magnesium, which is the metal. H2SO4 is the acid, which is sulfuric acid. MgSO4 is what?
Ma'am, magnesium sulfur.
Magnesium sulfate. It is called as magnesium sulfate. MgSO4 is magnesium sulfate. Now, you tell me, is this equation a balanced equation or not? See, I don't want your answer. You have to first of all solve it yourself, and then when I ask you, answer me whether it is balanced or not. Because I want everybody should answer whether it is balanced or not. And I will be asking you how you are saying that it is balanced or not. So I'll give you 2 to 3 minutes. Find out whether it is balanced or not. So Adrit, Ashwat, Divesh, Rohini, Kshitej, all should answer. Rishit,
Okay.
Ma'am, can you show on the screen?
whether it is balanced or not balanced.
Ma'am, it is balanced.
Ma'am, can
Yes, ma'am, it is balanced.
Kshitej, do you think so it is balanced?
ma'am 1 minute, ma'am.
Ma'am, it's balanced.
Okay. Okay, Rishit. Adrit, do you think so it is balanced?
Yes, ma'am.
How you are saying it is balanced?
Ma'am, like here Mg plus H2SO4. Like if we combine Mg and SO4 also, we can like add H2.
Ma'am,
No,
ma'am, it's balanced, ma'am.
it is balanced. See, no, Adrit, actually, how you have to answer that the reactant side and the product side. So reactant is basically your left hand side, okay? Now there we have to see whatever the elements are given. Magnesium is given, hydrogen is given, and sulfate is given, okay? Now we have to check whether the number is same on the reactant side and product side. So magnesium, how many magnesium are there on the left hand side?
Ma'am, 1.
Ma'am, 1.
1. And on the right hand side?
Ma'am, 1.
1.
1. Now coming to the hydrogen, how many hydrogen on the left hand side?
Ma'am,
Ma'am,
2.
2. And on the right hand side?
2.
2. Now coming to the sulfate, how many sulfate are there?
Ma'am,
Ma'am, 4.
4.
No, actually 1. So SO4 is 1 actually. Together it is counted as 1. Okay, so we will say as 1. And then on the right hand side?
Ma'am, 1.
Ma'am,
1. Okay. So that is how we say that this reaction is a what? A balanced reaction. So we should not add any kind of the number there, neither with the magnesium, neither with the sulfuric acid.
Ma'am, if it is only one molecule, SO4, why is there 4?
It has a molecule of oxygen there, not molecule of the sulfur. Okay.
Okay, ma'am.
There is a, see, if I talk about O3, if only O3 I talk about, it means you might have heard the word ozone, ozone layer. Have you heard this word?
Yes, ma'am.
Yes, ma'am.
Right. So only O3 means it's a triatomic molecules. It has 3 molecules of the oxygen. But here, what they have given this together, SO4. So here the molecule of sulfur is 1, but the molecule of the oxygen are 4 in number. Fine. So that is why we cannot actually, count it separately. We have to count it together. And if they have given it SO3, that is sulfite. Okay, the name change actually depending upon the number of the oxygen. Fine. Sulfate we have, sulfite we have. So like this, the numbers will be there. Okay, Shritesh?
Okay, ma'am.
Okay, now moving to the next reaction. Okay. Fourth reaction is the reaction of calcium with hydrochloric acid. Reaction of calcium with hydrochloric acid. Now solve this. How you will be solving it?
Ma'am, can you like write the equation?
You should try, Rohini. You try once, then I'll be writing it. You try.
And like, can you tell the
Symbol.
calcium?
Okay, symbol.
Ma'am, symbol of
Symbol
calcium.
for the calcium is capital C and small a, and for the hydrochloric acid is HCl. Now you write it. What will be the result?
And ma'am,
What
I'm
you have
done.
got, Rishit?
see, calcium plus hydrochloric acid, like I got the salt as calcium chloride, 2,
Correct.
and H2.
Correct. So this is the metal called as the calcium. Then hydrochloric acid is the acid. We have got the calcium chloride, CaCl2. It is the calcium chloride, and the hydrogen will be released.
Yeah.
Now again, the same way you have to do it. The reactant and the product, you have to check it. Now no one should answer except Adrit. Adrit, you should tell me what is the number of the calcium on the left hand side or the reactant side?
Ma'am, 1.
Correct. On the right hand side? On the right hand side, how many are there? 1. Now coming to the hydrogen, how many hydrogen are there on the left hand side?
2.
Hmm?
Ma'am, 1.
1. And on the right hand side?
1.
This is 1 or this is 2?
Ma'am, 2.
2.
Correct, 2. Now both the side have the different number of the hydrogen, right? So what we should do, we have to make it same number. That is the reason we will be adding the 2 here. Okay. Now tell me how many number of hydrogen are there on the left hand side?
Ma'am, 2.
Correct. And on the right hand side, how many are there?
Ma'am, 2.
2. Okay, that is how it becomes the balance. Going to the last one, chlorine. How many number of the chlorine are how many number of chlorine are there on the reactant side? 2. Okay, and on the right hand side also they are 2. So that is how the balance reaction is. Clear?
Yes, ma'am.
Okay. Now moving to the next one, it is the reaction of copper with acid. Maybe with the acid, मतलब hydrochloric acid we can take as. So copper is Cu and hydrochloric acid is HCl. Now you tell me the reaction what it will be.
Done.
Ma'am,
I'm done.
CuCl2 plus H2.
Like this you are saying?
Yes, ma'am.
Yes, ma'am.
Are you sure?
Ma'am, I guess. I guess.
Any other answer apart from this?
Same answer.
Same answer.
Ma'am, we have to give the
Okay.
we have to give the balanced equation or just the
No, just a simple reaction you have to give it.
Okay, ma'am.
Okay, so you all are saying the same answer, correct? The copper will be reacting with hydrochloric acid and it will be producing the copper chloride, correct?
Yes, ma'am.
Yes, ma'am.
No, this is actually the exception part of the reaction. Like how we have learned the exception for the metals and non-metals. Same way, copper reacting with the hydrochloric acid is the exception where no reaction takes place. So here, the copper will not be reacting with the hydrochloric acid, and that's why the no reaction will be taking place. Clear? The reason I'll tell you because, see, there are the metals basically who has the high reactivity and who has the less reactive actually. So some metals are highly reactive and some are less reactive. So when we talk about the copper, it is least reactive, okay? Because it is least reactive than the hydrogen. So whatever it is more reactive will be able to replace it, but whatever it is least reactive, it will not be able to replace it. For example, now if I talk about sodium which is Na, it will be reacting with the hydrochloric acid because it is highly reactive. Same goes for the magnesium. Magnesium, which is Mg, will also be reacting with the hydrochloric acid because it is highly reactive. The zinc can also react with them because it is the reactive. Moderate reaction will be there. It is not very highly reactive, but yes, it is reactive. Then the iron, it is also the reactive. That is why it is yes. But when we talk about copper, it is least reactive. That is the reason no reaction will be there. Then coming to the down of it is the silver metal, which is also what? A least reactive. It does not react with the hydrochloric acid. Then going to the next one, gold, Au. It will also not react because it is least reactive.
So metals
What?
which are high reactive only will react with high HCl, right?
Yes. Why now? I'll tell you why they will be reacting. Highly reactive metal can react with the hydrochloric acid because then only, if they are highly reactive, then only they can replace the hydrochloric acid. Like for example, we have discussed Na plus HCl, right? This Na is highly reactive. Now, this highly reactive metal actually should join with chlorine. Okay. And it should remove what? It should remove the hydrogen. Because it is highly reactive, they will fight and they will join with chlorine. But in the case of the copper, what happens? It is not very reactive. That is why they will not be able to replace that hydrogen. They will not be able to move that hydrochloric hydrogen and no reaction will be there. Understood?
Ma'am, so like basically the metals which are less reactive, like they don't react only with hydrochloric acid or all the acids.
Only with the hydrochloric acid. They can react with the other kind of the acid, like concentrated nitric acid is there, they can react with them. But the only hydrochloric acid, they will not react because this hydrogen, they will not be able to remove it.
Ma'am, so when hydrochloric acid is concentrated also, they won't react?
No. Whether it is dilute, whether it is concentrated, they will not be able to react with it.
Okay.
Fine. So this is very, very important part. Highly reactive, least reactive. So if I give you now any example of the silver, gold, which should react with the hydrochloric acid. So any reaction will be there or not?
No, ma'am.
No. Clear? So why the reaction is not there? Because there should be some element which can replace the hydrogen from the hydrochloric acid. If it is more reactive, then only that element or that metal can replace it. If it is less reactive, then in that case, that element cannot be replaced by the hydrogen. That is a reaction. That is the reason that the reaction will not be there. Clear? Now
Yes,
the next
ma'am.
one is the next reaction is which was the number 6 number. Okay. Now the next reaction is reaction of potassium with sulfuric acid. Reaction of potassium with sulfuric acid. The potassium symbol is capital K, sulfuric acid is H2SO4. Now what you will be getting?
Ma'am, potassium is highly reactive or less reactive?
Yes, it is reactive actually. It's a highly reactive.
Ma'am, potassium sulfate and potassium
Hmm.
sulfate core and hydrogen.
Now what you should write? What is the formula of potassium sulfate?
Ma'am, KSO4
KSO4 plus H2O.
plus H2.
Is it correct?
Yes, ma'am.
There is
Yes,
no
ma'am.
compound like this, okay? There is no compound which is called as KSO4. Always potassium sulfate. So some of the formulas, children, you should actually learn now, okay? So potassium sulfate, when we write it, the formula of it is K2SO4, okay? So this is the general formula of the potassium sulfate. When we write it K2SO4. Now, is this a balanced equation?
No,
No, ma'am.
No, ma'am.
What is the number of the K on the left hand side?
one,
Ma'am, 1.
1. And on the right hand side?
two.
Ma'am, 2.
So what we should do now?
Ma'am, we need to
Ma'am, we have to make 2K or K2.
Correct. 2K actually. So no, not K2. Don't make it K2 or the VH. Okay. When single element is there, then you have to add that number in the front only. Okay.
Okay,
Okay,
ma'am.
ma'am.
So now when we make it 2K, here also we have 2 and the other side also will get be 2. Now coming to the hydrogen, how many hydrogen on the left hand side?
Ma'am, 2.
Ma'am, 2.
On the right hand side?
Ma'am, 2.
Ma'am, 2.
2. On the right hand side also we have got 2. Now moving to the third one, which is SO4. How many are there on the left and right hand side?
Ma'am, 1.
One.
And here also 1.
One.
Okay. Fine. So I hope you have understood, like, how it is working.
Ma'am,
You can
after
write like this. You can write like this. That's up to you.
Ma'am, after potassium sulfate, is it like just H2 or is it H2O?
No, it is H2 only because water will not be released. It is hydrogen gas which has to be released.
Okay, ma'am.
Okay. Now, some of the reaction I'm giving you, kindly note it down. Okay. Which you have to try solving it. So Pb plus, okay, I should not write. You have to actually balance and then write it. Pb plus HCl. Then what will be the formation of it? Then the Fe plus H2SO4, what will be forming? Then the ninth one, Ag plus HCl, what it will be? Then Cu plus H2SO4, what it will be? Fine, try solving this 3 to 4 reactions.
Ma'am, what is PB?
Pb is lead. Lead, lead.
Okay, ma'am.
Ma'am, Ag is argon.
ma'am,
No, Ag is not argon.
ma'am, Ag is silver, right?
Correct, silver. And Au is gold. Fine.
Yes,
So any doubt now, children, do you have? No doubts? So do you think so I can teach chemistry?
Yes, ma'am.
Yes.
I can teach?
Yes,
Yes.
ma'am, you can teach.
Yes, ma'am.
Kshitij, I can teach chemistry?
Yes, ma'am.
I can actually, a small bit of it, I can teach it. But these are very, very important. Once you start working on this, you will be, liking it very much. How it works, why it does not work, when it reacts, what happened, what kind of the formation will be there. So this is very, very minute part. We have started, reaction of acid with the metal, which will be giving the salt and also releasing the hydrogen. But yes, what do you need to do, children? You have to actually now work on yourself to learn the metals, the name of the metals, what are they, and the non-metals name with their symbol. Okay, so once you know what is metal actually, what are the examples of metals, what are the examples of non-metal, then automatically, if any reaction is being given to you, you can apply it, right? You can solve it then easily. But if you don't know what is a symbol, you cannot write it, because always in the reaction, what we should do, we should use a symbol. We cannot write magnesium or hydrochloric acid. We cannot write like that. That is not the rule actually. So for that, learn the symbol of each and every metal and non-metal with the examples, with the correct spelling of it, and then which is more reactive, which is less reactive, and all that I will be teaching you then and there. Like this example has come, I told you what happened. Highly reactive it is there, or the least reactive metal it is there. Fine. So then and there, whatever the examples will be coming, I will be teaching you. And in the next class, we will be now working for the other type of equation. So this was the first one, which is acid reacts with the metal. The next class, the other type of equation we will be discussing. Yes, Shitej?
Ma'am, all those elements are from the periodic table, right? All of them.
Yes, yes, yes. It is from the periodic table only. So anything, children, you want to ask? Ashwath? No. Okay, children, then try solving this. And if in case you have any doubt, you can ask me. I'll clarify it. Okay?
ma'am.
Okay, children, then. And be whatever timings I'm posting it, children join during that time, because see, I think now it is 38, almost 1 hour class it was there, right? Because if I start by 6:40, I cannot take it like for 1 hour. I can take only 20 minutes. So before I can start, I can take for 1 hour. I don't mind taking it. Fine. So in 1 hour at least you can learn very good things on all.
Okay.
Clear? Okay, children. Then thank you.
Thank you, ma'am. Bye.
Thank you, ma'am. Bye, ma'am.
Thank you. Bye bye.